Um, yeah, I'm called Bex. I think that's an alias. It's short for my surname. It's Dibakwane, which was further shortened to the Bex. And some felt friends shortened it further to Bex. So it's a name that stuck with me for a while that I've had. So yeah, in terms of the objective for today, you can move on to the next slide, Mtlokwa. So what we want to do, basically, we're going to explore data science, and in particular, we're going to be looking at over and above the slides that we're gonna over and above the slides, we're going to be looking at what data science is really. We're going to try and understand why AI, what are some of the prerequisites that we have. We're going to try and differentiate between what is the difference between data science, machine learning, artificial intelligence, deep learning, reinforcement learning, and we can also try and fill some questions that you guys might have. And to make it stick, we're gonna go and look at the practical. We're gonna do a practical use case where we're going to just focus our energy on EDA, that is exploratory data analysis. So that's gonna be hands-on, but I think I might have a problem sharing on my side. I've got a new laptop, and I think by default it doesn't want to share on what you call this on Zoom for some strange reasons. So what I might do in that regard for productivity, I might just share it with Mtlokwe, and then we can walk through what I prepared. I will see if that's going to work. I'm still going to try some tricks on the side. But in any case, we're going to go through an EDA project. And the purpose of that is to cover some of the aspects that we do in data science. So what are those? We're going to be looking at how do you source data from different types of data sets? How do you, that will be on the, how do you source the data set data? How do you then go about doing your data pre-processing? What is data pre-processing? How do you identify missing data? How do you handle missing data? And what are some of the key important things in EDA? What is EDA at large, and why is EDA important in the field of data science? And we're not going to, for today's session, we're not going to go into the actual modeling, whether that be linear regression, logistics regression, or decision trees, etc. We're going to focus on EDA, and I will explain the reason why that is the case. The next slide, Mtlokwe. So what is data science? I think it's a term that is thrown around quite a bit, that we obviously have heard. There's a gentleman who coined data science as it's a data scientist is a computer scientist who also understands statistics, and it is a statistician who understands computer science. I think we are all familiar with computer science or IT. I'm loosely choosing to use IT and computer science the same. They're not necessarily the same, but we all know, I think the first thing that comes to mind when we think of computer science is programming. Basically, in loose terms, computer science is the science of computing. These are the guys that come in to bring about, integrate computers into science, basically. So this definition says that a computer scientist, a data scientist is a computer scientist who also understands statistics, and it is also a statistician who understands computer science. So in other terms, data science is is a mixture of, it's a combination of computer science and statistics. And statistics is, it's the study of numbers, or the study of statistics, your mean, mode, range, all the different statistics that we have. You may have also heard that data science is the sexiest job of the 21st century. I think this was a gentleman from Google, or a former Google employee, or one of the big shots in Google in 2012. I just forgot his name now. He coined that phrase that data science is the sexiest job of the 21st century. So if you look at the diagram that you have, if you look on the right side, there, in terms of the domains that are there, that play a role in as far as defining what data science is, we've got maths and stats on your top right. I think I've labored the point in that regard. And then on your left, you've got computer science and technology. And on below, you've got a business domain that you have. And you've got things like traditional research, and you've got software development, and you've got machine learning. So we're going to get in, I will explain further as to what is machine learning. And then at the sweet spot of all these domains, the sweet spot that you get when you take maths and stats, when you take machine learning, when you take traditional research, when you take business understanding, your subject matter expert, your product owner, and all that, when you take software development, computers and tech, the sweet spot that you get, the commonality that you get in all of that, it's basically a data science. So data science it's unique in that it combines all these different aspects in order to get you. It uses all of these skill set or domains in order to achieve what it sets out to achieve. So, I mean, on the left, that's pretty much telling them telling the same story. The input is you got a lot of data sources. It's data driven, as we all know, and you got a lot of data systems that come into play. There is some data engineering that that happens, and then there's data science that actually mix all of these domains in order to achieve what is the objective that is set out. Look at the next slide. And again, if you've got any questions, colleagues, I don't know how the procedure is, if they can unlock their mics, if you unlock their mics, or if they can put on the chart. So I've got the chart open on my side. If anybody has any comments or questions, feel free to interrupt at any time, and via unmuting yourself on the microphone or on the chart, and then I'll be able to attend to that. So, what is artificial intelligence? So, in the 1940s, 1950s, there was a gentleman, an English gentleman by the name of Alan Turing. He was just one of the voices that was recognized at the time. This was like after the boom of computer science, or of programming, after IBM made the big machine that was filling up the room, and we've sort of, mastered computers. There was this obsession within science of creating intelligent machines, and that was coined artificial intelligence. So artificial intelligence is the clue is in the term itself. Artificial intelligence. So real intelligence will be considered as human beings, and then any intelligence that is created by human beings that mimics human beings was therefore coined artificial intelligence. All that it says is the objective function there is we're trying to create machines that that can mimic human beings. We're trying to bring human intelligence into machines, or we're trying to create thinking systems. That is broadly the definition of AI. You may have heard of the so-called Turing test. And the whole objective with the Turing test really was to test that for any given system, can that system fool a human um, to a point that they are not sure whether they're still interacting with a human being or they're interacting with an artificial with a bot or an artificial intelligent object. Then the second part of that is machine learning. What is machine learning? So in order to, it was an accepted thing at the time, and it still is at this present moment, that one of the key distinctive features for human beings is our ability to learn. And what then scientists did is they went and categorized the different types of learning, and that is covered in different spaces of sciences. But the key, the three main key subtypes of learning that we have is we've got supervised learning, and the clue really is in the name itself. Supervised means that there is a human being or there is a supervisor who is involved in the middle, who is assisting maybe with interpretation or anything that's got to do with that domain. But the key thing is, in order for that learning to happen, there's a supervisor, and you and I are a product of this. We went through schooling, and in the school there was a supervisor. There normally is a teacher who is facilitating the learning. Another form of learning is unsupervised learning. So unsupervised learning is pretty much the opposite of supervised learning. In this type of learning, there is no supervisor. What are the in machine learning, what are the categories of supervised learning? The categories for supervised learning is linear regression and logistic regression or classification. In linear regression, the applications for linear regression is time series, such as when you're trying to predict what is the stock performance going to be. I'm sure you've all seen that. Yeah, and there's many other time series is just a typical examples. How is the share of a certain company XYZ going to trade like in the coming 12 months? That is one application of linear regression. So pretty much what the core objective of supervised learning is, we're trying to predict what the future is going to look like, knowing what we know about the past regarding a specific entity. And as human beings, we utilize supervised learning quite a lot. We normally judge things in the future based on how we know or we've identified a certain behavior in the past. And then what are the subtypes of unsupervised learning? In unsupervised learning, in machine learning specifically, we've got the two main big types being k-means clustering is one type, and we also have hierarchical clustering, and you've got other specializations that I'm going to cover in just now, such as deep learning and reinforcement learning. So what you're trying to achieve in k-means clustering, basically, it's when you're trying to do things such as customer segmentation. I'm sure with the advent of online shopping, maybe via Takealot or Amazon or anything, or even Facebook as well, when you befriend somebody, or you receive a friend request from somebody and you accept that, say on Facebook or on LinkedIn, and then the algorithm suggests to you that, oh, you may also know person X and person Y and person Z. How does the algorithm know that you might know that? But it's virtue of association. So they're using key attributes that define neighborhood that says, if I know Mtlokwe, I potentially know Mandla Magagula, I potentially know JD Skosana, because perhaps we share a key characteristic. That characteristic might be that we studied together at University of Limpopo. It could be location, it could be key interest, it could be any key attribute that identifies. So that's how machines or algorithms know this is how we associate, and that's how customer segmentation gets to be done. Semi-supervised, a semi-supervised machine learning technique is where you take supervised learning and you implement some supervision where it makes sense and no supervision where it doesn't make sense. So that is just a hybrid or a combination of the two. As mentioned just now, deep learning. What is deep learning? Deep learning is it's a specialization of machine learning, and what it really does is it uses a lot of mathematics, a lot of calculus, and we have three categories there in artificial neural network, convolutional neural network, and recursive neural network. So what it all tries to do, the essence of it really is that we're trying to, one of the key distinctive features of a human beings and how we learn is we've got neural networks in our bodies, and data data is processed through the central nervous system between the different parts of the body and the brain. And that central nervous system facilitates decision making, and really it's a stream that facilitates intelligence. So deep learning, all that it aims to do, it's use mathematics to resemble neural networks in the human body and how it goes about achieving intelligence, and basically implement that on machines. That's pretty much what deep learning is. And I think there was some clever what do you call this? Some clever branding that went into that. The usage of the word deep is just to say that it traverses or goes through a huge amount of neurons in order to compute the outcome that it needs to. And lastly on this, or second last on this, is reinforcement learning. Reinforcement learning is also another type of learning that we as human beings do, that scientists have actually adopted and make it part of learning for computers. So what it all does is, as human beings, we normally do this, most especially with kids. When kids do what we like, or if we set out an objective for kids and we say, go achieve this, without telling them how they should do it, but just describing, okay, these are the rules, don't jump these rules. If you jump these rules, we're not going to give you a reward. If you follow these rules to the T and achieve what you set out to do, we're gonna give you a reward. That's what we do as human beings. When kids go to school and they pass, we buy them something. We give them a reward, you know, whatever that reward looks like. So in reinforcement learning also is a type that we've adopted as scientists to then implement this to say, can we achieve learning without any supervision, or can we achieve it in a supervised manner? And pretty much this is used in gaming. Predominantly, it's used in gaming at this point in time. There's other use cases where this is used. And now, having defined all of this, the simple meaning of data science is, as you can see, is the culmination of using all of these techniques, all of these machine learning techniques, in order to achieve a system that is artificial intelligence, or that can be defined as artificial intelligence. So data science is pretty much using all of these practices in achieving an intelligent objective. That's another way of defining what data science is. Mtlokwe, next slide. Just one back. I think there was 2 slides that Another one back. Okay, cool. Go forward. Okay, what is data? We all know data is information, but it's not just information. Data can be noisy as well. What is information within the data? Information is what we call a signal. It's useful things, useful data that can tell us something very useful. What is noise? Noise is anything that is that's not telling us any useful information. A signal is good information. Noise is things such as missing data, unclean data, data that is corrupted on that we are looking at. And some of the key things that you need to consider that speaks to data is the whole aspect of overfitting. So this implies more when you're going to be doing your modeling, or the notion of overfitting and underfitting. Basically, an overfitting model is a model that tries to, you typically, what you're going to do is, if you've got a data set, you're going to split it between training data and testing data. So if you've got a model that gives you 100% accuracy on your training data, but gives you less than 50% on your test data, we typically say that model is overfit. It performs well on test data, but when you deploy that model in production, that model suffers. In simple terms, that model cannot generalize well. Just to give an example, let's say you've trained a model that's going to recognize cars, and then you give it a sample of 100 cars, and it can it can pick up all of them. And in training, it can tell you that this is a BMW, this is a Mercedes, and it can also tell you the model, this is a 3 Series of a BMW and it's colored black, etc. Now you take that model and put it somewhere. You deploy it and put it in a robot somewhere. And then all of a sudden your model is telling you that all the cars that are coming through are Toyota Corollas. And we know that is pretty much, given 1 million records or 1 million captures, it is pretty much impossible that all of those cars are going to be Toyota Corollas. So that we classify that model as an overfitting model. An underfitting model is the opposite of that. It's a model that will pretty much it pretty much doesn't perform as well. So what you want to do is you want a model that is not overfitting and that is not underfitting. You want a model that will be able to perform and score and achieve accurate results without too much noise, just in the middle. You want it to be on the sweet spot. That's pretty much what you want to do. So things that you need to be aware of with regards to data are the aspects of outliers. You need to be aware of things such as biases. For instance, if you're training a facial recognition algorithm that's going to detect the faces of people, and you train it on a male-dominated data, that algorithm is going to be male, it's going to have a bias towards males. Because it's been trained on that, it will tend to identify certain types of males versus women. And what I mean by that is there's also the issue of color or race as well. If you train a machine learning algorithm based on a white-dominated male data set, it's going to perform much better when it sees white male faces than when it may see, for instance, other males of color. So one needs to be cognizant of such biases, and you, as you go about modeling your solution, you need to make sure that your data set is representative and you sort of take care of such biases. And the other things that you need to take care of or need to consider in your data is variability. So you pretty much, I gave an example of cars. If you've got say computer vision project that you're working on, you typically don't want to expose your model to only Toyota models, unless if you are doing a project for Toyota. But even in that case, if your subset is Toyota, you don't just want to focus only on Toyota cars. You want, only on a certain model of Toyota, say Corolla, for instance. They've got Bakis, Kumbis, buses, etc. So pretty much your solution should be diverse. So you must have variability in your data set so that you will be able to, your algorithm can generalize pretty much well. Look at the next one. So why data science? Data science is the new gold. We live in a data era right now. So data is called, it's been coined the new gold. So there's a data boom that's happening with the advent of social network, with the advent of digitization, with all these 4IR, initiatives that are happening. Everything pretty much that we are doing is data driven, as you say. So there's that boom of data. Data is the input that from which data scientists thrive on, hence data scientists. So data is the new gold. Artificial intelligence can be described as the new electricity. Everything that we are most likely going to be doing in the future is going to be powered using AI. It's going to be powered using artificial intelligence. So yeah, just like electricity right now powers each and every economy in the world, that's how we see AI going to be. AI is the key enabler for our economy. It's a number one enabler. Millions, there's a lot of use cases that we have based on data science that you can use. So pretty much data science can be used in any industry. It can be used in sports, it can be used in financial institution, it can be used in the agriculture and construction, in the fashion industry. There's lots of, the use cases are endless that are out there where we can be using AI. There are tons of data, I think we've covered that. Data science has been open source, and I believe that probably this is the number one accelerator that has put AI to where we are. In the data science community, we say that we are living in the summer of AI right now. So pretty much it's a boom. It is easy to access, and I'm going to touch in the coming slides, I'm going to touch on open AI platforms and tool sets that one can use. So they are very much easily accessible. It's very easy. There's a lot of support, tons of support online if you want to take the journey of being a data scientist, or if you want to utilize the tool sets in data science. Lots of support online, lower cost to access AI. So the cost to access AI, the boundary has been lowered quite dramatically. You talk about the next slide, please. Cool. So we're going to be using there's pretty much two big languages that you need to in the learning of machine learning, or in the practicing of machine learning. The number one most used one, I'm going to use it number one in quotes. It's Python, and I'm going to focus this on Python. The other language that you can use is R. You can also use Java as well. There's some libraries that have been developed for Java. You can also use C++ as well. But the two biggest one, or the three biggest ones that you get, is Python leading the way, followed by R and SQL. There's other machine learning languages that are coming in on the fore, There's Julia that is also on the fore, and a lot of course, we've got a lot of Java people in the market. Java has also been adapted. There's some special libraries that have been adapted. The same for C, the same for C++. But let's just assume that because we're going to use Python for our session, let's just assume that predominantly a large amount of people use Python. So why is Python popular? One, Python is open source. It's got a friendly code context. It's robust. It runs quick like C, and fast like C++. It's clean like shell scripting. I'm assuming that in our audience, some of you might have a programming background. So some of these things that I'm talking about here from a language point of view, you can resonate with. It's clean like shell scripting, and it plots like MATLAB. It supports object-oriented programming, some standardization and structure. It has a huge AI library. There's quite tons of libraries: NumPy, Pandas, SciPy, sklearn. You mentioned quite a few. There's other libraries that have been, hyperscalers that exist out there, such as AWS, such as Microsoft Azure, and many others out there that are commercialized and that have been created that are an extension of Python. So there's a lot of support, and Python. This I think for me is what sets apart Python from a learning point of view. It supports high abstraction, and what I mean by that is, and I'll be able to demonstrate this if I'm able to share the code on my side in a short while. If you are to write a hello world program in Python, all you need to do is to write the following code: print open column, inside quotes, hello world. That's all that you need to do in Python. In Java and C and C++, you need to import a whole lot of stuff. You need to write probably about 5 lines of code just to say hello world. And that was done intentionally. In order to scale up and go into achieve AI, a language needs to be able to support abstraction. You need to be able to do less and achieve more. That's pretty much what it means. There's lots of support on YouTube, on GitHub, on Kaggle. Code less and achieve more. There's a lot by using vectors and processing. Python has got what we call notebooks, or IPython. We're going to be using a notebook for today's session, and that helps to articulate ideas in a much better way. Because of the high abstraction, that means you're putting little effort in order to achieve what you need to do. Smart data mining, excuse me, Python allows you to, it's got some libraries that are pretty much advanced, and without much effort, you can mine a lot of data. But having said that, there's a lot of open data sources available online that you can use. Great documentation as well. Next slide, Ntagwa. Okay, I think you can go to the next one from this. Yeah. Quickly, I want to touch on this, and then I think we're gonna go into our use case. What are the different platforms that are there? I might have mentioned some of these. Kaggle is probably the biggest. What is Kaggle? It's an open data science platform where everybody can join. You've got people who are coming from no maths, no programming. They've not done any programming before. They go into Kaggle, they get in. It's a bunch of like-minded people. You register your profile. There's a lot of data sets, a lot of learning material that you can get, and people literally move from 0 to hero in being a data scientist. They've got some of the best data science competitions where you actually win money. So that is an open data platform, probably the number one or the biggest in the world in as far as data science. And then there's Zindi is a similar one. It's open globally, but it was started it focuses on Africa. So in actual fact, the CEO of Zindi is from South Africa. The founders, the co-founders of Zindi are from South Africa. So these are platforms that you can go and join in order to meet like-minded people like yourself if you want to learn data science, where you can learn more, exchange ideas, learn from other people. And since data science has been open source, you can actually get their code. And actually, if you are solving a similar problem, you can actually learn from what they've done, and you can adapt their code into your one and achieve what you want to achieve. GitHub is where you would source your code. Is a social platform for Git, basically. That's where data science code is and many other codes as well is saved. So you can get, as I said, it's open source. You can get Google Colab. If you've got an account with a Gmail account, you have access by default. You have got access to Google Colab. They are hosting a Python IDE there, which is free, and you can use their computing for free. They've got a community version of that. And I mean, Google has contributed a lot in data science in Python alone. They've got a libraries such as Keras and TensorFlow, which is used especially for deep learning. And I mean, I've already mentioned on the right, there's a lot of support on data science from YouTube, Google Search, Stack Overflow, Kaggle, and GitHub. The next slide, please. Yeah, so somebody might say, okay, what do I need in order, if I want to change careers or if I want to study data science, what do I need? I think the biggest one is discipline. Yeah, you probably can achieve anything in life if you've got discipline alone. Most people fail because we lack discipline. I think that's the main thing. If you want to pursue this, set out, draw up a project, draw up what you call a plan of sorts, and stick to that. If you're setting aside time per day, if you're setting aside 30 minutes per day, make sure that you stick to that. And those small steps will ensure that you end up achieving what you need to do. Curiosity, be curious with data. Look at data from different aspects. There's a saying though, as you go in your data, you'll understand that all models are wrong, but some models are useful. So, and the reason why that is the case is, in most often than not, we don't have the most complete data in front of us. We've got data that is complete from a certain perspective. We don't have complete data from all perspectives. So that's a question of coverage. And then community, be part of communities. I mean, on the previous slides, I've shown you the communities that exist. I would strongly suggest you join those communities. It's a community of like-minded people. And you would probably need a very good laptop or a PC, at least minimum that has got 8 gig RAM. Some of the data processing that you're going to do are quite extensive. I see there's a hand from Andile. I don't know if you can unmute them and let them ask.
Yeah, Andile, please. Yeah.
Okay, thank you, Elisha. I just wanted to comment on the last point where you said that you need a 16 gig RAM machine. If you have internet, you can use Kaggle and run your things. I think Google Colab does give you GPU power and computing power. I mean, my computer has got 4 gigs of RAM, but I can run computer vision things using the power of Google Colab.
That's definitely true. That's yeah. So if you don't have your own personal computer, but you've got access to the internet, you can go, as I said, if you've got a Gmail account, you got access to Google Colab. So you can just go on Google and type Google Colab, and you log in. You log in using your Gmail email, and you'll have what you call a Jupyter Notebook that you can use, and it's free of charge. So yeah, that's a very valid point. That's very much true there, Andile. Thanks for that. Is that all you wanted to say? Is there anything else?
No, that's all. Thank you.
Cool stuff. Thanks for that. Mtloko, next slide, please. So hypothetically, if you wanted to take a journey into data science, pretty much the learning journey will some pre-learning that you would have. I would think is mathematics and some programming that you might have, whether that be Java or whatever, HTML, etc. Any programming that you have would be to good use. But if you don't have, pretty much just utilize any online sourcing that you can get, unless if you are enrolled on a structured program that you might have. Unless you're going to be using either Python or R or any other language, but you pretty much need the fundamentals. So you learn the specificity of data science. That's what this is speaking to. And there is some statistics that you're going to need to get, some business statistics that you're going to need. And as we've learned, data science is the culmination of computer science and statistics. So you're going to need some statistics. And what you're going to need here is understanding is inferential statistics, is descriptive statistics. You're going to need to understand data distribution. You're going to need to understand what we mean by the mean, the mode, the frequency, the range, and the standard deviation, the variance. You're going to need to understand the different types of the distribution of data, whether that is normal distribution, binomial distribution, Poisson distribution, gamma distribution, geometric distribution. So there's quite a bit of statistics that you need to learn. But I can assure you, I know a lot of people that came in without any statistics background, and they actually are still doing well. And also no programming background, and they are doing well as data scientists. My way of saying it is, as long as you are willing to learn, you should be fine. You shouldn't have a problem. We spoke about supervised learning. That is, you need to cover linear regression. We spoke about also unsupervised, you need to cover classification. And you also need to cover ensemble techniques. That's the different ways of achieving the same thing. So there's different decision trees, random forests, boosting technique, and all that stuff. You're going to learn about model tuning, and there's simple model tuning that you can do. There's advanced model tuning, and then there's unsupervised learning clustering. We spoke for our papers, we spoke about k-means clustering, and there's also hierarchical clustering that you can learn. And then there's also association, that's your k-means clustering. And there's a lot of data visualization that you actually get to do. And having said that, and then you pretty much get to do a capstone. A capstone project is pretty much where you bring everything that you've learned into one project where you get to solve a use case of some sorts. I don't know if there's any question there. Next slide, Mtlokwe. Cool. So I think we covered some of these use cases. There's millions, there's tons of use cases. In Formula One, there's tons of use cases that you can get in retail, geo-marketing, recommender systems, in the healthcare spaces, in sports, game strategy, live analytics, insights, almost any industry. It's safe to say pretty much any industry is matured right now, is a candidate to use data science. I can't imagine any industry where you cannot use machine learning, actually. Yeah, Next slide, Tlokwe. I think there's a comment from Koketsu saying, will we please get the recording? My PC is acting up. I think, yeah, that should be sorted. I suppose Tlokwe did mention the session was recorded as far as I know. Yes, it has been recorded. So what are some of the opportunities that exist in data science? You can, with a data science skill, you can become a data analyst. A data analyst is a person who pretty much analyzes data and extracts some insights on that. The difference between a data scientist and a data analyst is a data analyst pretty much doesn't do any modeling. All they do is they analyze the data, they get high-level insights and all that stuff, and that's all they do. You can become a data engineer. What's a data engineer? A data engineer is a role that pretty much comes in before a data scientist can do their work. They organize, they automate data pipelines that feed data into a platform where a data analyst can get the data and start working on it. And you can also become a data scientist. I think we've explored that. You can become a machine learning engineer. What is the difference between a machine learning engineer and a data scientist? Pretty much a data scientist is going to model a solution the best way they know how. They will come up with their best model for a specific problem. But what normally happens is they don't productionalize their model. Some do, but it's not expected of a data scientist to productionalize their model. A machine learning engineer is then somebody that takes that model that a data scientist has created and structure it in such a way that it can run. It's a code that can run in production. So they pretty much support a data scientist in that sense. You can become a bot designer, you can become a bot author, you can become a roboticist. Typically, that is when you have a reinforcement learning. You can become a bot trainer, you can become a researcher. Yeah, and there's a lot of other opportunities that you can do as well. Mtoko, next slide.
The hand helps from Mr. Nene. I believe it's Mr.
Yes, Mr. Nene can go.
Yes, Mr. And this one. Okay. Thank you for the question.
You are breaking a bit. I'm not sure that maybe it's me from my side.
I can't hear quite clearly as well.
You are breaking. Yeah, try again. Yeah.
Oh, okay. Okay, can we hear now? Maybe let me be quick. Give me my break. I will type out my question.
Okay, I think that should work. Elijah.
Okay. Yeah. Cool. Is there any other question? Any comment from anybody? I'm just. Okay, cool. So he's going to type out his question, right? All right, next slide, Mtoko. Okay, cool. So we're gonna get into our case study now. So we're going to look at use case as
I think, sorry, Andile shared some, oh, these are the courses, right? Andile?
Yes.
Okay. All right. Yes, okay, please proceed.
Cool. How do I close the chat and just focus on, there we go, that is gone. So in terms of the use case itself, and sorry that we can't be going through this programmatically together the way that I would have liked. If you can zoom in a bit, make it a bit big. So the data set that we have, and we'll be doing a little bit of scrolling. Mtoko, for me, bear with me. The aim is EDA, and for this purpose, we had about 3 data sets that we're going to be looking at. But we don't have to worry about uploading and and not, because I've just made a snapshot of the code that I've sent to you. So you're going to be looking only on that screen. But pretty much how you're going to be using this is you're going to be using Anaconda. I'm using Anaconda or any other Python distribution that you have, and you're going to be using, so you're going to be using, like Mtlokwa has, so that one, Jupyter Notebook. So you pretty much, we're going to be using a Jupyter Notebook as Mtlokwa is, and then you go and create. So what I can do is this. I will make sure that I share the data sets with Mtlokwa, and I also share the notebook itself, because it's open source, and you all can have access to it, not just the HTML part of it, the actual notebook itself, and also I will share the data set as well, and then we can all go play around with it. But then for now, we're going to go through the EDA. So in terms of the context, this is a loan provision company. Find it hard to give loans to people due to their insufficient or non-existent credit history. Because of that, some consumers use it as their advantage by becoming defaulted. Suppose you work for a consumer finance company which specializes in leading various types of loans to urban customers. You have to use EDA to analyze the patterns present in data. This will ensure that the applicants capable of repaying the loans are not rejected. So what you've got customers that are classified. Classified as to those that can repay and those that are defaulted. So you say you work for consumer finance or it's a bank. That's the exercise that that you need to do. If you can scroll down, just scroll. I will tell you. Scroll down, scroll down, scroll down. So if you can stop there, then in terms of
the case, which
just go to the approach. Just go to the approach, maybe. So how we're going to approach this is we're going to do some data pre-processing. We're going to do some univariate analysis. This will entail analysis on all individual features or columns. Features or columns means the same thing. Bivariate analysis or multivariate, this will entail analysis of two or more features and their underlying association or relationship, as well as the 5 most correlated features that we have for this. So as a data scientist, what you typically expected is you would typically you would conclude based on the data that you've been given. You will outline key insights that you've generated and any actionable insights, and also you'll make some recommendation, right? And then if you can scroll down now, we're starting the code. So you would remember I mentioned that Python has got some key packages that you can use. So in this case, we import NumPy, we import Pandas, we import Matplotlib, and we import Seaborn. NumPy is a library that is used for, it stands for numerical and scientific calculations, calculations that you can do. And then Pandas is a library that we can use that works the same way as Excel or as a data. It's a library that you can use to generate data frames, basically. Are you going to create? I
want to try that so that we have that boom boom thing, right? We don't just want to talk. Yeah. Yeah.
The challenge is that you won't have the data set.
Oh, okay. All right. Yeah. All right. No issues. No issue. Let's go. Proceed.
Yeah.
Okay.
Okay. Cool. So, in terms of then Matplotlib is the library that we're going to use to visualize our data. And inside that big library, there's a sub library called PyPlot. I think that's first descriptive. And then Seaborn is a specialized library. It's a specialized library of Matplotlib that pretty much helps you to do some advanced plotting that you can do. So what happens below that is we are setting some options. We telling Python these are the max rows that you can display, and these are the max columns you can display. These are the width that you can display, and the max info width and the max column width that you can display. Because it's got, by default, it's set to some specific length and breadth that you can do. And the last thing that we are doing is we are suppressing any errors that Python might want to display. We say just ignore those warnings, not errors, rather those warnings, just ignore them. And the first thing that, as I indicated for this specific use case, we've got 3 data sets. The first data set that's given is the data dictionary. And and how you go about, we're going to create an object called calls, and we're going to use that by using the read CVS meaning comma separated files. So on my desktop, I've got this data set called column_description.csv. So when I do this association and I call that by typing calls.head, it's going to display the top 5. And as you can see in there, so it's got the column index on your left, and it's pretty much has the table. It tells you from which table this data it's got, and it tells you the rows that that you can get in there. It pretty much gives you the top 5. So the purpose of this data set that we're given is a data dictionary. It's going to tell us these are the columns that we have in terms of the rows, and these rows, this is what it means. This is the description that that you have. That's the sole purpose of this. Other than that, we're not going to use this data set for anything else, right? So if you scroll down, the next line is pretty much, I wanted to remove, if on the previous output that we had, you had that, we had 2 indexing that we had, and I pretty much wanted to set an index, and this is how you define an index in Python. If I want to set an index, I go to my data dictionary object that I've created, which is calls, and then I use the dot notation. I say calls.set index, and I specify the column that I want to set as index. I put it in quotes, and when I enter that, this is the output that it gives me. So pretty much, if you can scroll up, please. No, scroll up, not down.
Okay.
Up, yes. Just to show the difference, if you can scroll up. So this is what we had. Unnamed, pretty much, I want that to be my index, because you see it starts from 1 to row 1, 2, 3, etc. But on the left, you've got that 0, 1, 2, etc. So I just wanted to add simplicity there. I made that uname as my index, and if you scroll down clockwise, then this is the output that comes out pretty much. This is now our data is indexed according to as it's given for us, and it's got all these rows and columns and all that stuff. And that's just your data dictionary. So your data dictionary is what typically it will be the data that you're getting from your data engineer, and your data engineer would have gotten that from whoever the technical team that would have given him. That is your data dictionary. It tells you this is the data that you want, right? It's for referential purposes. You're not going to do any computation on that. Then the next thing that we're going to do, Mtoko, you can pass the output up to you can go up to 5. So the actual data for the loan, for the loan application, the new loan application is called application_data.csv. That's the file that you typically would have on a server, or you'll have on your data set. As I indicated, I'm going to share this notebook, and I will share the actual spreadsheet file on its own. That's titled application_data.csv. So it's sitting on your directory. In my case, it's sitting on my home directory, and I am creating a data frame called df. I'm going to use a function read_csv because I'm reading a file that's stored in a CSV format. And when you run that, it's going to create. And how do we know that the data frame has been created without any errors? We then going to run. We're going to call that. Is there a question, Mtokwe?
No, I think the Kumar was just saying that please share the data, but I think you mentioned that you will share the
yeah,
the
definitely.
data.
I will at the end of the session. I'm going to share the data with you guys. Or are there people that are following through that would should we rather I share the data now?
Yeah, because I thought perhaps maybe even there's no complicated. I think it would be easier, right? I just paste and then you see the actual results and. But obviously, maybe the time is no longer on the site. But you can quickly then just go through this.
I'm going to share the data set quickly. I think that will help. Will be to everybody's benefit.
But we're left with 5 minutes now, so we don't want to hold friends for so long.
Okay, so what should we rather proceed and then I share it?
Yeah, then we'll share it later.
Okay,
yeah.
cool stuff. All right, can do that. So if I use the sample, pretty much what this is saying is sample, and then it's saying go into my data frame and pull any random 20 rows of my data frame. That n is the number of rows that you need, or the from my data set. So Python is then going to pull out any 20, and the reason why I want to pull any 20 data set randomly is because if I go, typically what you would do, as we've done up there, you would pick up the top 5 or the top 10 in your data frame, but you also want to have a feel of your data set as well, to see is my in terms. I mean, we spoke about missing data. How is my missing? Do I have any missing columns and all that stuff? So if I go and pick the top 10, what's likely to happen is your top rows probably have got correct data points inside, but you don't know if that is the same for all of them. So if I use a sample, which is going to pick randomly, it's going to give me an overview for the 20 rows that I'm going to pick. So this is now the view. There's your column name starting from left. That's your SKID customer. That's a unique customer ID that you have. And then you got your target. Remember on our target, when we were reading on the business objective, it was mentioned that there are customers who are defaulters and there are customers who pay when without defaulting. So in this case, 0 is a customer who pays without defaulting, and 1 is a customer who has defaulted. So that's your target. That's your target field. Contract type. In this case, again, if you go on and use the data, the calls data frame that we've created, that it's your data dictionary. It will tell you what is the contract type that we have. But in high level, I think we got cash loans and different types of contracts that you have. Gender, we all know it's either male or female, or it can be non-binary in certain cases, and it will be represented as such. Own car is a flag that shows, does the customer own a car or not? So as you can see, I mean, you're getting a feel for it. I think, if you can scroll to the right on that same view. So pretty much this is a layout of your data. You can see the count of children. You can see the amount credit. You can see the annuity. The annuity is the payment that one must pay to the bank. And the number of seats, you can see whether what those are. So pretty much it's giving you a quick overview of your data. And there's a lot of columns. I think if you want to know how many columns, how many rows do we have, we then use the shape function, which is pretty much the next section that we add. If you can scroll down to the next one. So on that one, if we then type, our data frame is called df. If you type df.shape, it's going to tell you the number of rows that you got and the number of columns that you've got. In our case, we've got 122 columns, and we've got over 300K rows that we have. So pretty much, as you can see, this is a huge data. It's a huge data set that we have, that we are looking at, and that typically is the case in business. You typically be dealing with a large number of data sets. Therefore, you need a large processing power. So it will either mean that you're running either on a server, you're doing a processing in a server, or you can run that on a very powerful personal machine that you have with you. Then the next line, I'm trying to check the data types of my columns by using the command dtypes. And what it displays is, it tells me skid underscore, it's a type of int 64. So Python supports the following data types. It supports int 64, it supports objects, and it supports float type. So what is an int? Is an integer, and it's a normal integer like a number 10 or the number 0, the number 1, etc. So pretty much that's telling you what the type it is. And float, these are normally numbers with floating points, and those are like your currencies, etc. Any your longitude, latitude numbers, any number that's got a floating point after the comma, those are typically your float types. And then your object types, pretty much those are what we call categorical variables, such as gender. For instance, gender is not a number, but it's either a male or female. So that's what we call categorical variables. So what you pretty much do, if you can scroll up for me, please. Okay, good. So just go down slightly for me. I'll tell you where to stop. Yeah. This is harder than coding, right? This is harder than showing it by code yourself. So what you pretty much do is, you can see there, I've put in some notes. I say we observe that our features as per the above have the following data types, and that's pretty much what I've explained. We've got integers, we've got objects, and floats. And then this is pretty much what you want to do, because you're probably working as a team. You're collaborating with other data scientists or with other people. So you are noting your observations about the data, because really the whole objective about EDA is that you are as a data scientist, you are exploring your data, you are getting to know your data. So you are pretty much helping yourself by noting everything that you're seeing, so that as part of you gaining knowledge of the data, you can easily recall because you've noted down everything. So I strongly recommend, it's a great practice for pretty much all data scientists do this. Note your observations as you go. The next
yes,
slide.
yeah, Mr. Jibagwan, and then of course maybe the French also will maybe indicate, right? It seems that there's still few things for us to look at here, right? And then we are already, I mean, 25 minutes to 5. And then our session was 1 hour 30 minutes, right? So I think this seems to be very interesting to most of us, because I see friends are still sticking around. So I wanted to check, but maybe it's something that I should maybe talk to you outside to check. How's your availability? Maybe during the week, Wednesday, on what maybe Tuesdays, just to go through this, because I believe this is a core of what maybe most of us were here for, right? So that you can just get that gist of what this is about. So my suggestion for now, I'm not sure, maybe colleagues can go for another 30 minutes. I mean, like 25 minutes to 5 or 12, or maybe we can maybe have another 45-minute session, maybe on Tuesday, for example, at 7 p.m. Perhaps just 30 to 45 minutes, so that we can just go through this. I believe then we will, because I really prefer the real stuff in the sense, if it's a practical, you should do a practical. You cannot be mixing the practical and theory. It doesn't really click in my view, right? So I'm not sure what is the feeling from you friends.
I'm available on Tuesday. I'm available. We can take an hour or 2 or 45 minutes. I'm available on Tuesday.